Hi Goran, welcome back.
Hi, Adam. Is it Adam Bean, like good, like a Bian? Like how do you say that? Or Adam Bean?
It should be actually Bjorn, I think,
Bian.
because I find out that roots are somewhere in France, but everyone says Bean and always was Bean, but it could be Bjorn, and I actually don't care. I was in France, then in a workshop, then I of course said I'm Bjorn. Everyone liked that, and in Germany is Bean. So and of course there's the Englishman Mr. Bean, which also is funny. So so I'm actually, and I told you maybe this already. Back then, I delivered some Sun courses, Sun microsystems about enterprise Java beans, and no one believed that my name is actually Bean. So yeah, it's all good stuff for marketing, I would say.
Good.
Now, to summarize, you are, I think, the third time here, and the problem
Yes.
is we always have a nice chat without any structure. And the last episode was actually highly welcome on Twitter, which is nice. I mean, we had just a random chat about Java, serverless, and future. And to summarize, is you attended once the AHX Live workshop in Munich, and
Yes.
I told you something about simplicity, and you believed me, and then you wrote a Java EE application with your team with transactions, and this you tried to migrate it to Hetzner, which also works well. Then you migrated once again on AWS, and then you locked down, or you maybe you performed the largest the largest how to call it, what
Transaction.
happened,
Yeah. It
the
was
largest transaction in the history of AWS, and then and then you had
then I
some
became
insights.
AWS hero. So because I was complaining about that. Why did that happen? And then when your first reaction with these cloud providers is that, oh, this is not good. They made a mistake. There's something really bad about these guys. Something like so. Your first reaction is that something is on their side, and then as you go deeper, then you really start to understand what's going on in the cloud. It's completely different place. It's not your local data center. So the truth is somewhere in between, and it's a shared responsibility. So you have to understand the cloud better. And then they need to understand maybe some open source technologies better. So, but the whole transition that we talked about from Java EE to some cloud resources, it's not easy. You have to really think in a different way. I was like in the last two episodes, I didn't really like prepare anything like before. I was just jumped into, but
Yeah.
After the second episode, I was like, because you said, okay, let's meet again. I was actually thinking about what things are important for our listeners, and in this transition between Java EE and what we have now in the cloud. So I recently tried some technology called long running actions in microprofile. It's actually an implementation of a saga pattern. Like for listeners, like saga pattern is a way to fix the problem in the cloud where there is no distributed transactions. So if something goes wrong, you need to compensate. If you have to go back, so you always have to. You always need two actions: one to go forward and one to go back. If something happens, and it's a good thing. It's a solution for some problems, because in the cloud, there are many APIs, many different servers. There are many different instances that you have to call. So if you want to really be consistent at the end, you need to delete something or go back. But it's not the only solution. So what struck me, like when I really enjoyed that. The possibility to have some kind of a framework that will help to do this, in Java EE. And then I saw that they have some kind of a
Step functions?
core. They have open microprofile introduced something like a coordinator server. for this thing, you know. So all the servers playing this game need some kind of coordinator server to whom you send your idea about the transaction. Oh, I'm going to do this. So you get the number, and then you go forward, and then you send the number. Okay, this is my transaction. And if something goes back, the coordinator should call these services and go back. You know, I was disappointed again, you know, because in
but
the
what
cloud,
you mentioned right now, this was the key problem of two-phase commit.
Yeah.
There was the application server. I don't know if you remember. You had, I think, experience with Whitefly. There was Aruna, what they bought. And what this thing did, it remembered locally what happened. What the problem was is distributed transactions. You call the first database, and this is like begin, then prepare for commit, and you have to remember what you did. You get the transaction ID back, and then you go to the second database, do the same. What can happen is, you know, that the transaction coordinator breaks. So, and if it restarts, it has to remember what happened. Otherwise, you get deadlock for ages. Yes. So, with the Saga pattern, there's no difference. It's actually a distributed transaction coordinator, if you think about this.
Yeah, but the thing that you have one server, which is coordinating other servers, that's something that it doesn't work in cloud. You know, you always need to get out of that paradigm that you need one central server to do something, you know. So when you think about the cloud, you should think about no servers, like especially no coordinator servers, nothing that will have the idea of all the processes, all transactions, anything, you know. So there should be no one point of failure, but also like no central knowledge, you know, about the whole system, you know, so something like that. So I was thinking, like, how do you replace this in the cloud? And it's important for people to understand that even we don't want to have central coordinators, we still need some places where we will guarantee that something will not happen twice, you know. So people, like, even in the cloud, you need to find some places where you can do some synchronized stuff, you know, like, or so the way developers do that in AWS is to have one table in DynamoDB which will control the duplicates in some places, you know, like even if you try to do distributed things, you know, you still need some places where you will have a guarantee that something will happen only once, or where you will keep the information, you know. But at least in AWS, that place, that DynamoDB table or something, like, is something which is already distributed, and AWS is thinking about that. It's still not one server, you know. So
this table actually is, right, because the consistent hash is one partition of the DynamoDB, so it is a kind of a one server which is distributed. But this particular case, if we have the locking table, I think because of the keys, it will remind on the entire trick in one server.
It will, you know, but it's still distributed, and it guarantees that you won't be able to save two instances of the same key in one table, you know. It's still distributed. You can call it from different places, and you don't have to care about the servers and stuff like that. So, you know, even if we don't want coordinators, we still need some coordinators, you know. If we want to achieve idempotency, if you want to guarantee that something is saved or not saved, you still need some place to keep that information. But please don't do that by making one server that will coordinate all these things, you know. So in AWS, DynamoDB table proved to be a perfect place to do that. And
why? Because it's transactional, right? Because DynamoDB actually supports real transactions. What you need.
Not really about that. It's you can have your write operation can be conditional. Okay, so can I insert a record? I will insert a record only if there's no such a record in that table. Okay, so it guarantees that only one will succeed. Okay, so that simple operation allows you to do some idempotency checks, you know. And if you're using I really suggest everyone to check. There's a library called PowerTools for Java, for in AWS, for Lambdas especially, and there is a recent release about that, where they actually implemented that for you, so you can easily add idempotency checks in your application. Okay, so in cloud, you should get rid of that idea of having a distributed transaction and move to a more like a relaxed space where you can do stuff and then fix them. You can maybe fix them by doing rollback using Saga pattern of some kind, okay? Or you can let it go and then have some inconsistent state in the database. So but you can handle that situation. Like I don't have. Maybe you should just have smart queries that will just detect that the thing that is saved in the database is not consistent, so you will ignore it. So anyway, you have to move to a more relaxed space, but the thing that you cannot accept in your application, especially in enterprise applications, is you cannot do some things. Some of the things you cannot do twice. Okay, so you cannot charge twice. You cannot, and the way you achieve that, you need a single place where you can check that. So that the perfect one was actually the DynamoDB table. So that's
the interesting
a good
part of that AWS Lambda PowerTools is that the idempotency check, how this is implemented, is interesting. So what are they doing? This is a kind of an AOP. They are intercepting the Java Lambda calls, and then you can either specify a key, this would be the key where they are looking, or if you don't do this, they will calculate the hash of the payload of the parameter. So and then they use the hash key as the or the hash value as the key. So if you get the same parameter twice with the same values, you get the same key twice, and they will notice that because it already appears in DynamoDB, and they will ignore the second call, which is really nice.
Yes.
And you said the conditional, which reminds me, we had this in JPA for years. It was called optimistic locks. So what you could do is you say, okay, I'm only writing to database in case it's in the state. And if it's not in the state, then you got optimistic lock exceptions. And what we did with it is we could have a locking without database locking. This is without deadlocks. This is what you experienced. But if you would use that at AWS, you wouldn't be a data hero right now. So so good luck for you. Good for you. But the problem with this, of course, is if you have lots of or not the problem. The fact is, what we have in the cloud right now, we had on premise for years. For instance, the idempotency. So if you have a Whitefly application server, WebLogic back then, and very early, EJBs were remote. And if they were remote, there were so-called smart proxies. And you could set up the idempotency on the proxy level, because if exception happened, then the proxy decided should redo this or not. So there was like automatic reply, and this only happened in case it was idempotent. Otherwise, you could get duplicates. Also, JPA was always the case that you could use synchronous locks on. There was the optimistic locks and pessimistic locks, the synchronous pessimistic locks, which of course could lead to deadlocks, which already happened in production. So we had to use optimistic locks. The problem with optimistic locks is that they can fail, and then you need some kind of retry mechanism, which can be very expensive. And the problem with the cloud, or not problem, the fact is, it is even harder because on premise, we only had one availability zone, not even a region. And in the cloud, you have the same problem in multiple availability zones and even multiple regions. So it is really a lot harder to have one singleton, which is, completely distributed. Yes. And I think the only thing which actually an AWS is like this, or one of the few things, one would be S3, which is not exactly transactional. It is transactional, but only, if you write new stuff. or DynamoDB, which is also distributed. If you look at Kinesis and all the others, they are just regional resources. So it's not that easy to have a global lock. But the interesting part is, again, if you are a Java EE developer, you had the problems 20 years ago. You only have to remember how we solved that and what to do with them in the cloud. And you mentioned the long-running transactions or long-running actions, LRA, from microprofile. Yeah.
Yes, yes.
What this reminds me strongly, what I would use is step functions.
Yeah.
So the step function on AWS is like a state machine, and you don't have to use everything, but at least retries are actually nice, and error handling. This is, you can say, in case this doesn't work, I call Lambda from outside. This is like already the server, but is maintained by AWS. How they maintain it, I don't care. So it runs, the state is in central place, and it will call the first Lambda, and if it doesn't work, you can say, if this doesn't work, call this one. So I would use this instead, for instance, right?
Yeah, so of course. So why I mentioned this is that even if sometimes you have a feeling that things are happening synchronously in AWS, they're actually not always synchronous. Like, for example, AWS Lambdas. If you call Lambda function from API gateway or any other source, you don't actually direct the server web server call to another server which has these functions. You actually put all these requests into a queue, and then there is a puller that pulls all these things from the queue and invokes these functions. So it's actually possible for your request to be called twice. Even if it's coming through REST API, API gateway, going to your Lambda function, it still goes asynchronously, into this system, and it can be called twice. So you need to take care, even if you have a feeling that it's a web server call. It's actually not, it's just happening so quick, that you don't really realize that it's asynchronous, but it's actually asynchronous in a queue, and it can be called twice, So any action with Lambda can be called twice. So people should be aware of that and start, if it's something which is mission critical, then you should have these controls in place, idempotency controls, So. And some things, it's, as you know, some things are not easy to fix. If you send an email, or if you send the email twice or 1,000 times, you cannot you cannot revoke them. You cannot, you can revoke some charge on the credit card, but that's not something that happens automatically and stuff like that. So there's always something which is like going out of the system, and then you don't have a way to revoke that. So. In every step you should think about idempotency, and sometimes, if you see that you can fix it later by smart queries, something, let it go. Okay, and always think about if this thing executes twice, would it cause any problems in the system? So having stuff like conditional write in Dynamo, and of course you can do that in MySQL or Postgres stuff. So you have unique constraints on tables and similar things. So you should always use that to control the double invocation of a function. That's something that will help you remove this the whole concept of distributed transaction XA. So that's something that is absolutely necessary in the cloud, And
or you can use, you mentioned the REST lambdas, you could use the HTTP correctly. So if you say get is idempotent, post is not idempotent, so you have to be careful here. But put is idempotent again, because with the same key I would insert the first time and update the second time. So I would have an upsert, for instance, right, with the put, and delete doesn't matter if I delete stuff twice. So if you be more careful how you design your REST APIs, they are idempotent except post, and even post could be idempotent, because what you can return to the client is like the next ID and then use it again. So but this is nothing new. But if you have a distributed application, highly distributed application, which is usually in the cloud and multi-region or whatever, the chances are higher that it happens. So this is the only difference, I would say, to before.
Yeah, and also the problem is that you have to understand that when we put all these requests for Lambdas into a giant queue, okay, and that queue keeps all the requests, and it also has limits. It's a tokenized system where you get by default 1,000 requests, 1,000 invocations per second. Okay, so you have to, if you have more than that, and you can easily get into more executions. Like you need to ask for more. It's just, by default you won't get more than that. But it's a giant queue, so you have to think about.
One question about that: have you recently opened an AWS account? Recently?
Yeah. Okay. Yeah, I did.
Because my impression is my account is older, and I have also a limit of 1,000. But it seems like if someone created a fresh account recently, they have concurrent execution of 50. So it seems like the new accounts, really complete new accounts in AWS, are more restricted than the old ones. Because I never had the restrictions. I never had to increase them. For me, it was always like, I think the AWS organizations like 50 accounts and concurrent invocation 1,000. But the newer account is not like that. There's like, the limit of 10 for organizations and I think 50 of concurrent invocations. And I already had an error because I couldn't deploy the CDK app in the new account. It was on my client. And so I never saw the error. Like what I wanted to have.
Yeah, but maybe if the account is not verified, there's some
maybe
some
something like this
of,
interesting. Mine was also, but my account is so old, and even all our sub accounts. I also know they always come with the 1,000 limit, and I thought it's the default, but seems like not to be, right?
Well, the first time you register, you get some. They need to go through some process of verifying your account, like credit card stuff like that.
Maybe
and even after a month, you can still be in some state where your code build, for example, cannot run. That's crazy. I mean that the billing part is one of the most criticized part of AWS. Like because it should be easy to jump in, should be easy to control your expenses, should be easy to control, like if I don't have any more money, just stop billing me, stop all the services, and there's no way to control all these things. So yeah, they need to improve. Like what others are doing is better in that way. But on the other side, they assume that we know what we are doing. We're smart people. So that's it. But still, you're right. There are some issues when you create a new account, and if you see some limits, like you cannot run the code build or whatever, just call the support. And again, the problem is with the support that if you don't pay for support, like $100 a month, which is a minimum for paid support, you will get response in a couple of days, so that's not something that's good, if you're starting, but if you're serious, pay $100 and then you get a response in an hour. So it pays off.
No, sure. No, I just noticed that because it happened once to my client. They opened a fresh account, and some attendees of the AWS Live workshops also had the same issue. It seems like the newer accounts are more strict about the limits than the older one. And maybe, I don't know how old you use AWS account, I think 2010 or something like this. At the beginning, there were less complaints about the billing, and maybe some people now become angry because they tried something out and it was too expensive for them, and they lowered the limits. This is what. Well,
it's good. The good thing about AWS is that if you start complaining, you may get something. For example,
you become a data hero.
Yes. But I'm saying that, for example, 2-3 months ago, we actually deployed a couple of provision concurrency functions, which means that my Lambda is always running and is always there for me to call it. So, and that thing costs more. And the problem is that we actually we picked the biggest possible Lambda in Docker Lambda of 10 gigs, So we end up with a bill, which is like $400 a month, just for a couple of 3 lambdas or something, just staying there, not doing anything. That was crazy. So you can call them. You can call support and ask.
Wait a sec. If you have provision concurrency, what could happen is that at the end it is cheaper because you are paying less for invocation. You did the math?
Well, it can be cheaper.
It can be. If you go to the if you have provision concurrency and the lambdas are running, then if you call them within the provision concurrency, you're paying less per invocation. So if the lambdas are executed a lot, you could actually save money with provision concurrency.
Yeah, maybe it depends on what
just
you
try
do.
It. Just saying, maybe in your case, whether you pay 500 euros up front and then at the end, 200 euros more or 800 euros in the entire time. So this could be the difference.
The good thing about if you need some speed, then it's okay. Like the first response, like to be really quick, then it's fine. But if you talk about billing, it's not actually that big thing. Because if you use languages like Java and TypeScript and JavaScript and something, and deploy Lambda functions, then when you call Lambda, you have several steps for it to start. Okay, the first one is like it's called cold start, and during that first phase where the all Java classes are being loaded and where you, for example, establish your connection to the database, stuff like that, you actually get that part of the invocation for free from AWS. You don't pay for that. Okay, so you pay only for the execution part. So all the static initialization, all things that happened before they call your request handler, it's free. If you can complete it in 10 seconds, okay. If you don't complete it in 10 seconds, they restart the Lambda, but this time they charge you. Okay, and it can run more than 10 seconds. So it's a good thing actually, because if we had to pay for all the cold start time Java has, we may be charged more than others, So that's really fair, because what happens when Java lambdas start, they're actually faster than any other environment. That's super cool. That's something I'm really proud of about Java. But you get them, you get the cold start for free. It is a bit higher, okay, but it's free. So in terms of
so you're running lambdas behind the load balancer, right? Out as well.
Well. In many different
because
environments.
There's a nice little hack with load balancer. What you can also do with load balancer, you can ship your Lambda with microprofile health enabled.
Yeah.
And what I do sometimes, I use the load balancer to have an health check on the Lambda, and the load balancer pulls the Lambda. So you get for one Lambda, if it happens every, I don't know, you have to play a little bit with it every 30 seconds, you pay basically nothing because it's like a low volume, and your one Lambda is always warm. So at least one start is faster, You can.
Yes. you can do that, but there's always a problem of second call.
Sure.
Parallel call. So.
But for development, it's great. And what I also do for development, I usually use always provision concurrency, because it runs on AWS. I don't have to wait. It's like crazy fast. So I save time, and you pay 10 euros a month or whatever, but it is worth, because you save a lot of time, and you get a high performance Lambda.
So recently, Lambda function environment became even richer. Like the building this whole environment in a way that now you can have 10 gigabytes of storage for ephemeral storage. So like, what could happen in the future is that the whole code build and other code build is a parallel to Jenkins for listeners, is that they should be able to start the code build process, CI/CD process, like in in a millisecond and run it really fast and then kill it. So that's something that's probably going to happen soon. Because this is going in that direction. Because Lambda functions in Docker are so impressive. Like 10 gigabytes starting in a couple of seconds. That's really impressive.
Yeah, and there's I think they have you mentioned the ephemeral store, but they have I think 10 gigs of RAM as well, and 6 CPUs now, not 4, right? They increased it to 6. Yeah, it was 4 before. Now there are 6 CPUs.
So it's really becoming the way they should. They I cannot say it for them, but you can actually do the whole build of in Lambda. You don't really need any EC2 instances or something like. You don't need servers to do that. So I assume that by the first Lambdas had many more limitations. Like the only limitation that is relevant now is maybe this 15 minutes execution time. So that's something that people need to. The only thing that really bothers me sometimes, if something needs to run for more than 15 minutes, it won't run. So that's a limitation.
What bothers me,
the rest is fine.
In Lambda is that they not use Java properly. So what it means is, the AWS PowerTools project, for instance, what they have one annotation called idempotency. So you can annotate method with the annotation. And then they have this method is not invoked twice with the same parameter. So this is how the idempotency works in AWS Lambda PowerTools. What I'm asking myself, this add idempotency, they implemented in the AWS Lambda PowerTools with AOP. So what they're doing, they have a bytecode processor, and the bytecode processor, checks the annotations. But in my opinion, this has to be the part of the Lambda. So the integral part of Java is add inject. So add inject is not about microprofile. It was actually introduced by the Spring guys and adopted by Java, microprofile, Maven, Eclipse. Everyone uses add inject. A very simple one. Forget about profiles or whatever. What I would like to see in Lambda is add inject and whatever they store in the context. Add inject secret. Add inject, S3 client. Add inject DynamoDB client. What I don't like to do all the time is, DynamoDB client .create .whatever. This is like, Java from 1950s, This is, we don't do it anymore. And then if you do this, the entire Lambda runtime environment would be even more flexible, because what they could do behind the scenes, they could replace, the implementation with whatever they like. Right now, you have always write the same code, and you could, of course, do it by yourself or use Quarkus. But, for asynchronous Lambdas, why to use Quarkus if you get it out of the box? So right now, if I have asynchronous Lambdas, I don't use neither Quarkus nor Micronaut. Mm-hmm. I just use plain Java, what we did. But the only thing what I don't like, they're called like S3 client equals S3 builder. And what you always get, you get the arrow, you have multiple clients in your class path, choose one. Then you have to use the URL connection client or Apache client or whatever client you have. And if you think about this, logger, Lambda logger, system out logger, everything should be injectable. Whatever is in the Lambda context, it will be very easy injectable. And this is what I don't like. I had already a chat with a few people at AWS, and the problem is, they try to keep all the languages unified. But I don't care whether Python has injection or not. I would like to have one. And it is really sad that something like AWS Lambda PowerTools have to implement injection on top of already existing Lambda, right? So what AWS should do, just use modern Java for Lambda implementation.
What I see now is that they are a bit conservative, in doing things like that. And for example, the last discussion that I had was about should they, for example, if we already know that Lambda is running for a short time, and we already know what kind of environment that is. So why don't we set by default some environment variables for Java execution that will handle the way the compiler runs, And they actually didn't do that. What they did is that they allowed you now to set environment variables for Java execution, but they didn't set it for as a default.
Yeah.
But the thing is, in 99%, the life of that Lambda would be really short,
Yeah.
So they just want to be sure that everything works, and for everyone, and in terms of what you said, I would say that they still need to maintain some kind of all languages should have this almost same way of execution,
Yeah.
and but if you really want something advanced, maybe you should choose between Micronaut or Quarkus or something, So
But-
anyway, some of the things
but-
I already solved in Quarkus, like injecting secrets and blah blah blah. That's something that is completely normal there.
But I don't like to rely on Quarkus guy, to implement Amazon stuff. So I like Quarkus, right? But just saying. And if you look at DynamoDB, it's not the case, because in DynamoDB they have API which looks like JPA, and such an API is impossible to implement with JavaScript. So they are not consistent.
Yes,
If they
yes,
say it
you're
should be
right.
the same for all languages, so why they implement DynamoDB mapper for Java? And I'm not saying they should replace the common stuff. I would say it should be possible to inject stuff with inject in Java, because even Maven, if you implement a Maven plugin, is also inject available. If you have Eclipse plugin, inject. So inject is nothing, about microprofile anymore. It is available in all runtimes. And also what you said with the settings with JVM, it is confusing for Java developers, because in one part you hear everywhere, how it's called, undifferentiated heavy lifting, right? So in Java we have the ergonomics. So for years, and now in Lambda I have to care about my low-level Java stuff again. So it is sometimes it's hard to tell, what is actually covered by AWS and what I'm responsible for. And in the shared responsibility model, my expectation is as much convenience as possible. It should be better than in Java E, and the sad story is it is extremely easy to fix. It's not like they need years of research. I would say to do it in proof of concept way. I think dependency injection Lambda level could be done in a half a day. Of course, not at that scale, but just that it works is not a problem at all. And I saw many of my clients already doing this. Some's doing, with Dagger, with Quarkus, with all crazy own implementations, because dependency injection is a part of Java ecosystems for 10 years or more, 15 years at least, right?
But you see, with all this Quarkus and Micronaut stuff, like the whole concepts are changing. So maybe if you look at from the perspective of AWS, they started with Lambda like a couple of years ago, and they're looking at it, and they were not ready really for native Java and this whole thing, because you still can't use some of the things that they deliver with GraalVM. Some they're not really there, but it's they already have some kind of a legacy, so it's hard for them to do some really big changes, I would say. And so they're not. For example, they have this new HTTP client.
Wait a sec. The dependency injection for Java I'm talking right now is JSR 330. It was released in 2009.
Okay.
So this is no excuses. So this is and this is actually, and these are three annotations, and the next thing what I would expect is post construct. Just a simple post construct. Post construct, so you can say, okay, what this is the two things, and this is not like it should be the only thing. They could just do nothing, and if there is an annotations, recognize it. This is not like I'm saying everything has to be injectable only. Mm-hmm. You could still, this is like in EJBs. You can write EJB and still use, ignore the dependency injection completely and just use your own Java JDK 1.1 stuff. But this is what has, in my eyes, has to happen, and it should, because relying on frameworks. I mean, if you think about the shared responsibility model, right? What issues you get with Quarkus or whatever. So you will have to rely on Red Hat or Quarkus guys in order to patch all the AWS libraries internally. So I took a look already, if you just use AWS SDK, it is newer than in Quarkus Inside has to be. I mean, Quarkus, AWS moves faster, and you will have to think about patching Quarkus in order to get the recent AWS SDK behind the scenes. I don't like to care about dependencies. So my idea, as you know me already, dependency less. I don't care about your dependencies. I would like just to fully focus on business logic. So I would expect that inject is a part of the SDK from Lambda. So you just this is just how to call it is provider dependency, and I would just rely on the entire SDK from AWS for asynchronous Lambda. And Quarkus, I would like to use for specific reasons. If I would like to use JPA, I don't know, specific maybe JDBC connection pool or whatever, then I use Quarkus. But I don't like to use Quarkus in order to have better AWS experience out of the box. You know what I mean? So Quarkus is not job of Quarkus to fix AWS.
But it's obviously a job of Quarkus to fix a lot, because what they did is they changed. So maybe just maybe if you look at it from the perspective of AWS team, maybe you would just look around and see what the hell is going on. All these changes in Java in the last couple of years. This is why we're doing
the podcast. They will listen to the podcast and fix it.
Yes. But look, there are many. There's a lot of work. Whatever you think about, there is always a problem, and then something has to be improved. For example, now they're improving the whole events class, classes that represent events in Java. It's still like there's a discussion of how should they implement it. You were complaining about Lombok. I saw that. So there's always someone complaining about what's the style of this library. But the problem is some of these things don't work. So let's talk about style later. First they still have some work to do for some of the things to be really, really. Java is there, but for some things you still need to do some things manually. So they have some priorities and other. For example, they didn't release Java 17 support for Lambda yet. So there's obviously a lot of things going on. What we are, you and I, we're talking about serverless and Lambdas. But Java is used as most of the AWS is done in Java. So it's a lot.
But I'm
so
just talking about Lambda right now, right?
Yeah. I'm saying that
and
coordinating all these things.
I'm not criticizing in order to to say, okay, why are you not doing this? They already done it in AWS Lambda PowerTools. This is what I'm saying.
Yes.
So the ideas what they got in AWS Lambda PowerTools, which are part of AWS project, should become a part of the Lambda. This is what I'm saying. So this is like web components back then in the front end. So there was a project from Google where they Polymer projects, where the idea was it becomes leaner and leaner because in one part everything becomes a web component and the project will die because there is nothing else to do. And this is my idea of AWS Lambda PowerTools. Some core principles like annotation support should be supported by Lambda, and this part can move out from Lambda PowerTools. We don't need AOP anymore. We can just use the dependency injection. This is what I'm talking about. It's not like they have it already. So this is the idea. And my feedback to the Lambda events is if I would implement such an internal library at scale, right? So my priority would be no dependencies because I would like to control whatever possible. This is the gist of my feedback. And they use Lombok and Yoda time, which is nice, but I would say if I were in the charge of the developer, I would even re-implement some stuff in order to be in charge of everything, right? Because I'm really afraid of the external dependencies. I think for them, it is easier to implement this from scratch than review the external dependency for errors. This was my feedback.
It's just a couple of functions,
this really, is like, this is not a big deal. And I think it's great because, my point is the message of undifferentiated heavy lifting and shared responsibility model is not consistent. So I expect something different. I would say I don't like to care about however Lambda sets the Corretto is a part of is actually job of the Corretto team. I will rely on them of the expertise, and I would like to focus on business, right? Yeah. And maybe we have to talk about this because I think the expectation is different from them. They maybe think, the Java developers would like to control everything, which could be true. But usually, if what I do first, I don't have any, the garbage collector settings in Java, no, -X, nothing, and see how it works. If it's fast enough, I ignore it completely. It's okay, passed, right?
I had an idea about completely removing garbage collector. So, for example, if Lambda runs for a couple of minutes, So why don't you just run it and kill it, and then start another one? If garbage collector is stopping you or slowing you down in any way, just if it's like a short-lived environment, what will happen if we just don't have a garbage collector and just leave data there and just kill it? For example, I wanted to set up a function that would run only once.
Yeah.
It's possible. It's almost possible. Okay, you can get out of the function via system exit 1, and it would actually fail and then start again, and then in the next attempt you again leave it and it will kill the environment.
It's like AWS, back then. If you throw exception, it was restarted. Exactly. Mm-hmm.
Yeah, but you can actually kill the entire environment. So the entire environment can be really dirty, okay, and it will kill itself. So why I wanted to do this is because I was running Eclipse BIRT reports in it, and it's a mess. Once you run one report, and it leaves so many dirty things in the memory and disk and blah. So you just want to kill it, and then run again. So you completely clean environment. So would there be any benefits of not having a garbage collector in such an environment at all? So just run it.
But you could set it up. You can have a zero garbage collector, the official way in Java, and then it is a part of JDK, so it should be supported by Corretto. And I never tried it actually in Corretto, but it is available. You could actually set it up. Yeah. And do you remember the story about the missile years ago?
No, sir.
So they found out there was a missile, and the software had bug and memory bug. Mm-hmm. And they said it doesn't matter because this missile flies, half an hour, and this is enough memory to deal with the memory leak. And exactly. If it hits the target, no one cares whether with memory leaks or without.
Exactly.
And
that's the same.
This is exactly what you have with your Lambda.
Mm-hmm. So one of the things that when we talked about this, we just mentioned events in Java, and there's a library Java events for Lambda that has all possible events that come as a JSON, and then you can deserialize them using Java. So the one of the problems that people have with moving to AWS is that there's these events, you need to know them, you need to understand them, mm-hmm. and then all these events are just for Lambda. Because Lambda can be invoked in many different ways, So, but when you start it in a container, like a Fargate container, mm-hmm. then it's just a regular server. Mm-hmm. So what I'm missing is that, okay, if I have a BIRT report that I want to run for more than 15 minutes, mm-hmm. look, I would really like to have the same invocation way like that I have with Lambda. So I can say, well, look, this SQS will call Fargate instance. It will start, run, and then die. Okay, so I can choose: will it run in Lambda environment with its restrictions, or with a Fargate with its restrictions? But you cannot use the same events, for different executions, like for your own EC2 or something. So you need to make your you have to program it differently.
Yes.
Yeah, so what you could do,
you could have a Lambda which with the, let's say, I don't know, S3 or SQS event more realistically, and receives that and invokes and Fargate, not a service, rather than just a task with the information.
Yeah, but it will need to, it has to, it should be running already. That's the only problem. So I would like to start Fargate instance from zero, and then wait for a couple of seconds for it to start, like 30 seconds.
As a service, not a task service, so it runs all the time, right?
Mm-hmm. Run and then die when it ends. And also maybe for the audience, so there's some restrictions with Lambda which are important. You can mm-hmm. only run one thread at a time mm-hmm. with Lambda. You cannot run two things at the same time in same Lambda function.
You can use your thread pool, but not request.
Yeah, of course. Okay, every single request starts another instance of Lambda.
Yeah, exactly.
Okay, so you cannot control that. That's a mm-hmm. requirement of the system. Mm-hmm. But different cloud providers do different things. If you do that in Microsoft, you could actually have more executions of the same Lambda at the same time. Mm-hmm. Okay, so more requests can come into Lambda and run at the same time. So, yeah, is it good or bad? I like how AWS makes it clean, I really like it, But sometimes when you spend a couple of seconds to initiate that Lambda, and why would you waste another couple of seconds to start another one? Maybe we could get some gains by parallelizing it, And what if I can start Fargate and have parallel requests coming into it, just like I do with Lambda? So I can have my Java EE environment having like 5 parallel requests coming into it. So I would really like these things to be more flexible, So people coming into this world need to understand that these events are not the same. You need to map it in a different way. So that's a bit hard, So you cannot just switch all these technologies. You need to think about which one. So what I do is I use Quarkus to build the same code that I run with Lambdas or with or running in container as a task. So so it's the same code, like the same business logic, but just different entry points into these functions. So and then you can deploy the same thing into 2 different environments and run it there. But still, this mapping and sourcing event mapping it's a bit difficult. So
what I think what could help you, what I would do in this particular case, use EventBridge for both. Because Lambda listens to schedule events. I think it's a type of the EventBridge, and I think you can invoke Fargate with the same event as well. You could
you can. So there are many ways to dispatch.
But EventBridge is the hub. I think EventBridge could solve your problem, because the EventBridge you can have a routing, and you can even route to multiple buses, and then you need in Lambda just one type of event, this schedule event, and a Fargate as well. And my impression is that EventBridge getting more and more attention, is more and more popular inside AWS, and it's easier to deal with. And recently, it even they have like a global endpoint, so it is highly available. Yes. Which is also interesting. And maybe you should investigate EventBridge, because this could be really interesting, right?
I think that the EventBridge is the real big bust that we always wanted. So it's a good thing. But the only thing is that most of our applications are still like a front based, that we need to think more in a way that we should change them. Did you know there is a thing called synchronous step functions that you can synchronously call them?
And the other one is like fast. Synchronous. Synchronous is something like not fast.
It has a fast execution.
Fast execution, exactly.
You can get like a response very very fast. So there is a shift. We need to switch more to asynchronous stuff than what we had with our on-premise systems, with all these REST APIs and stuff. Is that we were stuck with a really tight system of REST endpoints.
Because we didn't have any events. So the main difference is I ignored the event-driven architectures. You attended the AHEX. Someone asked me, event-driven architectures. My answer was, forget about it. I'm absolutely not interested in emitting events first and then listen to them. It's just crazy. Yes. And but the difference in the cloud, everything emits already the events. So we only have to listen to them. So this is a huge difference. Also, the main difference between on-premise and clouds is, in clouds, SQS, SNS, EventBridge, EC2, even code build and code pipeline and code commit, they are already emitting events. And with Lambda, you can listen to them. So event-driven architecture is just out of the box possible. What you only have to do is to deploy a Lambda and have a source mapping between the Lambda and the event.
So in AWS, like when you move to it, it's more about the shift to event-driven architecture than anything else.
Yeah.
So here you can here. So here, it's not. I'm in my house and I live on premise, but I'm saying in AWS, like everything is event driven. So once you start thinking in that way, you will start emitting by also more events. So for example, in that event bridge bus, you can really emit anything. Any business events, any steps in your processes, and blah blah. So you would push more events than in your like a regular Java EE system, So the only problem is that if you can publish more than you need, you can publish millions of messages and then maybe
sure.
Read a
there
couple
should be
of them.
coarse-grained business events which make sense, Like in your case,
yes.
report is done with the results, comes event bridge, and someone else listens to it, and then of course you could even use the AWS PowerTools. What they do, they from SQS they offload the payload to S3, for instance. So you could use such tricks or not. It really depends on the size of the result of a report is not huge, right? In your case,
so what I realized is that one of the missing pieces in this game that people maybe should think about is that it's a GraphQL, it's AppSync. So if you do event-driven, if you make event-driven architecture for your system, and you push some events, and if you are waiting on the front end side for something to happen, you should wait for something that will come through WebSockets, or some mechanism like that. So the way to do that is GraphQL, So once your component in some backend system finishes its job, or it just wants to emit like a state of the process, it should emit that to this thing AppSync, which is GraphQL actually. And then you can subscribe to these events and get it back. So AWS has this entire architecture for you to move your strict REST APIs and move that to async. And you should embrace that as soon as possible. Once you do that, you will get more freedom. Like you will feel less limitations. For example, if you are worried, I can push only 6 megabytes as a request payload for Lambda, and in my Java EE server I could upload anything. I could push whatever I like. So if you are worried about some of these restrictions, you have to think about how AWS does. You don't deploy you don't upload anything to your server. You upload to S3. Once you upload the file to S3, it will emit an event. Event will you can say, okay, push information that this is uploaded to my GraphQL, and it will inform the server, the browser back. So the whole thing has to be a bit more complicated, but it will actually get you to the point where you have no limits. Which means like if you can have 5 terabytes.
You said complicated. It actually is simple if you think about this. If you have to upload something to S3, there are millions of clients already built in. If you would like to use Java EE to upload something, you need multi-part upload, and you have to implement it by yourself. So you will have to have a JAX-source endpoint which listens to the stream and writes this stream somewhere else.
Not only that, you need to accept 5 terabyte size file. And then take that file and upload it to another. To S3, so maybe you can stream it in a way, like maybe multi-parts.
Yeah, but still, you have to do it. But if you upload it to S3, you can reuse a lot of stuff. So this is almost done, and then you have to write a Lambda which receives an S3 event, and its S3 event you will see the key and the bucket, and then with another call, it's like 20 lines of code at most. You have the content. So it is in this particular case it's simpler, but you have
it is simple, But the good thing is once you upload the file to S3 bucket, you can emit an event to event bridge bus, and then on event bridge bus you can call a function to do something with the file, and then inform the front end or send an email or blah blah blah. So event bridge is there to connect all the services. That's it. So you see, we introduced a couple of services here that you need to embrace event-driven architecture. It's step functions. It's AppSync with GraphQL. It's event bridge, like a big bus. So these are all components that we kind of we had in Java EE, but it's just now moved to the cloud, and that's the whole idea of our talk, So if you do that with AWS CDK framework, you can actually build these things in Java and then deploy them.
Exactly.
So if you do that way, then it's not that complicated. So I agree.
Perfect.
I agree.
We are on time. We are a little bit structured. Next time we should be unstructured again, just to have a random talk. It's more fun.
We promised to talk about databases, and one of the things that's my specialty in AWS, and there's really some really good innovations in the last couple of months in that AWS. So I look.
So then next time, database news from Goran on AXFM. Okay, nice. People can find you on Aztec. What I learned.
Yeah.
This is
but mostly on Twitter. That company. Yeah, that's just a company. But
what's
Twitter is my place.
What's your handle?
Goran Opacic. Goran Opacic.
Yeah, perfect.
Simple.
So I would say, see you next time.
See you. Adam.
Bye.
Björn.
Björn, exactly.